So my name is Jack Hammonds. I'm a PM for the Windows Subsystem for Linux. I'm pretty new to Microsoft, about a year and a half. Previous to that, I had done a lot of web development on Macintosh and Linux systems, and didn't really see the Windows operating system as a viable place to do my web development. This product has totally changed that for me, and has created an entire environment for me to feel very comfortable in the Bash shell, using the open source tools and technologies that I'm familiar with.
I'm Gilles Couzam. I'm the development lead for the Windows console. I've been at Microsoft for 17 years, and most of spent my career in developer platforms. 3 years ago, I started with the Windows console, and it's just where I spend my time. I'm a console guy. You'll find that I always have command prompts, Windows opened on my desktop. This is just how comfortable I am and where I get my work done. So I'm going to let Jack talk about the WSL side of things, and I'll be back to talk to you about the console in a few.
Thanks, Joe. So to begin with, I'd like to offer a timeline of what's happened in the past year with the Windows Subsystem for Linux. So like I mentioned, we released this product last year at Build 2016. Lots of fanfare, huge response from the community. People loved it. But what we released was more of a technical preview. It wasn't that this was an unusable product. It was just that it was kind of rough around the edges. And by the time the anniversary update rolled around, it was still a product that, although it would offer some functionality to your everyday workflow, wasn't really a fully baked environment that you could trust on to do your development. Fast forward to the Creators Update. This is a stable daily driver that we released about a month ago. I mean, if you've been on the insider versions of Windows for longer than that, you've seen the changes and the improvements that have come. And we're really excited to talk to you today about some of those improvements. That's today. So at the end, we're going to touch on some of the upcoming features that will be coming out in the new release of Windows this coming fall. And there's some stuff in there that I think you guys will really like. But for now, let's focus on this middle section. What happened last year? What changes were made? And then we'll talk a little bit about at the end about what's coming. So let's back up a little bit. What is Linux? This is a very overloaded term, a very important term that needs some disambiguation, I think. So Linux both refers to the operating system, those user space binaries that we'll touch on a little bit later, as well as the kernel. And typically, they're kind of packaged together as one thing, but in reality, they're two things. It's the GNU user space binaries on top and the Linux on the bottom. In the case of WSL, that user space area is filled by Ubuntu, who's been a great partner with us for the past year on this project. And inside that package are things like standard libraries, basic tools, glibc, stuff that you'd expect on a Linux distribution. Importantly, on WSL, these are the exact same binaries that you'd see in a standard package. We don't change them at all. They're not recompiled. They're pulled directly from Canonical's website and hosted on the Windows Store. And then in our case, the Windows subsystem fits right in there in that kernel layer. It provides a kernel-level interface to the NT kernel, translating system calls from Ubuntu down into NT and back. So this allows you to run all of your ELF64 binaries. That's a binary specifically for the Linux operating system. Unlike a PE binary that would run standard on Windows, we now run all of your ELF64 tools, applications natively, unmodified, not compiled directly for WSL, compiled directly for Ubuntu. It's a system call emulation layer. It's very lightweight. By the time it gets on your disk and gets installed, it's about a megabyte. It's not big at all. Now, those user space binaries that I mentioned are about 150 to 200 megs, depending on the tools and applications installed in there. Importantly, this is not a virtual machine. There's no reserved memory chunk that you're unable to access. When you spin up WSL, the memory footprint is very light. And when you launch an application, it takes up exactly the amount of memory necessary for that application to run. This is a command line development tool. Like Jill said, we live in the console. We designed this for you guys. It's by us developers for you guys developers. And we're excited that you guys are just as psyched as we are. So now we'd like to launch into a short little demo to show you some of the features that the Windows subsystem has to offer. First, let's talk a little bit about how WSL works as we get that at the demo online. Oh, it's going to look at my face here for a minute with Windows Hello. Maybe. There's always a backup. OK, so let's launch into a demo about some of the stuff that I just talked about. So Bash is super easy to launch on Windows 10. It's as simple as just typing bash in CMD or using our shortcut to launch directly. What Jill has open here is the Ubuntu version of Linux. Now, we can run the lsb command and show you, or cat the etc lsb file, and you'll be able to see this is Ubuntu 16.04. Unmodified, running directly inside of the Windows operating system. All of the networking tools that you would expect are there, things like ping and ifconfig. This is vital for me when I'm developing for the web to check, do I even have internet? What's my network interface? Those kinds of cool tools that are available on Linux, if you know how to use them better, are now available for you. Additionally, the package manager is the same. apt-get install works across the board. We can do things like cowsay. Oh, it looks like cowsay is not installed, so we'll go ahead and install that really quickly. It's just the same apt command that you would run on Ubuntu, downloads it directly, queries Ubuntu's servers, asks them where the package is, and very shortly we'll be able to run cowsay. I know that you all are on the edge of your seat. Like I said, these are the same binaries that you would run on a standard bare metal Linux setup. Not modified, the exact same. And there's cowsay. WSL is pretty awesome. So in addition to any package that you could download, there's also support for things like Git and SVN. These as well are just ELF64 binaries that would run in Linux. And we can run Git and SVN just like you would expect. So here Jill's going to my desktop, and he's going to check out a Git directory. This Git directory he's checking out is actually where we keep track of our issues. I encourage you guys to go check this out and file any issues that you have against WSL or feature requests, or just generally to talk to the community and see what's going on there. Like I mentioned before, it's an incredible community that we're excited to be a part of. So here Jill has cloned this repo to my desktop. He can go into that repo. You can see that it's right there. It interacts with the file system just like you would expect. He's going to go run a git log really quick, just show you this is exactly what you think. And now let's try going out and looking at that desktop again. So like I mentioned, this desktop is the same files that you're seeing inside of the Linux system. So we can do things like make a directory, delete a directory, and all of that's going to work just like you would expect it to.
Oh,
sometimes.
It's in here.
Oh, perfect. Yeah, there we go. So thank you, Joe. So that was pretty cool. We got to see some of what WSL has to offer sort of on the surface. But how did any of that work? What was really going on there? Well, there's a lot of components that fit together to enable WSL. First and foremost, there's a console application. The console application is CMD or bash.exe. It's that black window on your box that lets you talk to the applications via text. It manages the input and output between the console manager. Then we have our session manager. This is a session manager on the WSL side to manage the Linux instances that are launched and negotiate with our LX core driver, which is really the heart of the Windows subsystem for Linux. This is reliant on a technology called Pico processes, and it encapsulates a Linux environment in its own instance. Now, everything running inside this instance is unmodified ELF64 binaries. We have a session init process leader that, like any init process on a standard Linux setup, brings the system up, launches the correct services. We've written our own and slightly modified the standard one that Ubuntu provides to trim down the number of services. You notice that when Jill's launched this console window, it was almost immediate. I mean, half a second at most before the window was up. That's not something to be able to do with a VM or if you ran through the entire init process. So we've pared it down and given you exactly what you need to get your work done here. And then really the meat of what enables this is the NT kernel. We're leveraging the networking stack, file system, memory management of the NT kernel with our LX core driver. So if we shuffle this around and show what a standard use case of this technology would be, imagine that you are in the console and you type ls and you want to run bin ls. Well, what happens is you type ls, the console interprets it, and hands it to the session manager, who negotiates and drives that input through the driver. It's handed off to the init process, who forks. This is a standard fork like you would see on Linux, and launches bin.ls. And this is where the magic starts to happen. Bin.ls has an understanding of which system calls that it needs to execute. We provide an interface to let it do those executions. So when it hits our driver with that call, we do an interpretation and determine, oh, it's doing this system call. We need to interpret that and send it to the NT kernel, let it respond with its information, maybe slightly adjust it a little bit in the case of ls, and provide it back to ls in the way that it's expecting. Once that happens, we can shoot all that information back out to the console application. And you see that on your screen. So that's pretty cool. How do we make sure that any of that works? Well, we have a four-pronged approach to our testing that has really helped improve the quality and stability of the Windows Subsystem for Linux over the past year. The first area is the Linux test project. This is an open source benchmarking project that's used by a large number of companies and individuals to test the validity and guarantee that the system call and file system interfaces of the Linux kernel are up to snuff. Now, importantly, a 100% pass rate on the LTP doesn't really mean all that much. It just means that we pass the unit tests in that test suite. If you go out to the blog post that we have written about this, which I encourage you all to do, it gets into a little bit more of the finesse and talking about, as we build in support for more and more system calls, our compatibility with our scenarios increases. And that's the second area of our testing, is our scenario testing. This is where we take unit tests from all the major languages and frameworks and run them on WSL as well as Ubuntu in a VM. And we compare those results. And I think you'd actually be very surprised if you would have used WSL in the creators or in the anniversary update about just how much that pass rate has improved. I encourage you to go out to the blog and check it out. It gets into, like I said, a little bit more of the finesse. Another area is our stress testing. This is something that we do internally. It really helps harden the system and make sure that we get at those hard-to-reach areas of the kernel that may cause bug checks or things that would cause degradation of user experience. And the last and most importantly is our community. This is you guys in the audience. You guys have made WSL what it is today, and the quality improvements that we have seen over the past year are largely due to the efforts of you guys letting us know what's broken, what do you need fixed, what feature do we need to work on next. There's a slide at the end with some information about how to get in contact with us and where our GitHub and user voice page are. I really encourage you to go take a part in that. Our community is really what makes this as successful as it has been. So speaking of that community, we use you guys really heavily in our feature prioritization process. So like I mentioned, we have a GitHub. We've got, I think this number is probably outdated, something like 2,500 issues have been filed. We look at every single one of those. We have an incredible community that gives us actionable feedback and helps us really dig into the meat of these bugs. The Windows Subsystem for Linux is an incredible project, but it's technically very challenging and sits at the pinnacle of what makes Windows different from Linux. And those technical challenges, supported by our community, are much more easily tackled. So that's led us to insights like the need to support Haskell right out of the bat, and iNotify and Java and interoperability, which has been a big topic, especially, and something that we'll touch on later. So going into some of the main features that were new in the Creators Update. First and foremost is the support for Ubuntu 16.04. Ubuntu has been an incredible partner with us over the past year. We're thrilled to be able to get on their long-term servicing branch. This is now default in the Creators Update, So if you are running the anniversary update, we won't automatically move you over to 16.04. This is because we think you're best at setting up your environment, and we'd rather let you do that. But you're more than welcome to update to 16.04 using the release command. The second top feature that I would call out is interoperability. This is the ability to talk back and forth between Linux and Windows. I think this is really where this project starts to get its feet, is when you start to realize that you can leverage both systems at the same time. You can talk back and forth, write applications that rely on both Linux things and Windows things, script for that environment. And piping just works like you think it should. We'll have a short demo of this, but this is pretty mind-blowing. iNotify. So this is a feature that allows files to notify the system when they've had changes or modifications or they're moved, things like that. It's extremely useful in situations where you want to build on a file change or build on a file save or deploy on a file save or grab logs on file changes, things like that. So we're thrilled to be able to support iNotify in the Creators Update as well. Another piece here is our networking improvements. There's no top headline that I can give you about our networking improvements that will tell the entire story. But in general, it has to do with compatibility. Networking is an enormous space, as I'm sure most of you are aware. There's so many socket options and flags and different ways to support different features inside of this space. And so we've been working with the NT networking stack to bring some of the features in the Linux operating system over to Windows. And where there's gaps, we fill those gaps. And this has enabled us to get really deep into some of the key differences between Linux and Windows and bring the best of those features over to the Windows platform. And this will allow things like ping and ifconfig to work very, very well. So in addition to those main features that headline this talk, I think there's an important point to be made about the fact that we have touched so many applications in the building of this product. Not that we've modified those applications, just the opposite. We've gone and seen what those applications are reliant upon inside of Linux and determined how best to support them. So things like apt and sed, grep, awk were pretty early on and something that we realized that we had to address early. Following up on that, support for different shells like Fish and Z shell, languages and frameworks from Node to Ruby, Rust, Go, all of these things we've run on the Windows Subsystem for Linux and ensured that you guys will have rock-solid performance moving forward, including support for system services like SSHD. There's a little bit of confusion about whether or not WSL supports things like daemons and cron jobs. The answer to that is, as long as the window is open and it's an ELF64 binary, we're going to run it. Now, we don't support running applications once that console window has been closed, but we've heard that feedback, and that's something that we're going to be looking into in the future. So for now, let's launch into a short demo and kind of look at some of those things that we just talked about. My computer is locking a lot here. There we go. Oh, there we go. We're going to change that later. OK, so we've got a quick demo, and we're going to talk about Jill's got Bash open here. Let's talk a little bit about those interoperability features that I just mentioned. So this is an important aspect of this product, is that not only do you get the features available on Windows, but you get the features available on Linux. And combining those two things together is where the real magic starts to happen. So Jill's going to run a command called tree, and this just lists your entire directory sort of recursively. There's tons of files in the system, so it'll basically never stop. Now, if you knew what you were doing, you could easily type Control-C and stop this process. If you didn't, what else could you do? Well, you could pull open Task Manager, find this process running, and just kill it directly from Task Manager. This is the kind of interoperability that we are super excited to be able to offer you, and something that is just mind-blowing the first time you see it. So in addition to process interoperability, we have path interoperability. So we bring your Windows path onto your WSL environment. This means that if we were to echo the path here, you're going to see things at the bottom like System32 and your program files in x86. So this just allows you access to execute those things directly. So if we did something like code, which is an alias to VS Code, the wonderful text editor that's available from the Visual Studio's team, this will just open Visual Studio's code directly. We didn't have to set that alias ourselves. That was something that was done automatically. You may need to specify the .exe if you're attempting to launch an application that does not have the kind of bash shortcut that they've created there. So in addition to being able to launch things directly from your path, we also allow you to pipe back and forth between the two systems. So if you're in CMD and you need access to some of those bash tools that we were talking about, instead of launching bash as a full environment, even though that's so quick to do, we can do things like call bash ls. So we could say bash-c ls, and that will run in the current directory and list out, in this case, everything inside of System32. So in addition to that, we could pipe these two things together. So we could say bash-c ls, and then pipe that into grep, or the other way around. Or pipe that into FineString, or the other way around. So these kinds of just quick tips and tools and tricks that allow you to do these kind of fun text munging things in your console without having to launch into a specific environment makes it really easy to get your work done very quickly. So another thing that's new in the Creators Update, and something that you will have seen if you've been on Insider builds for the past month or so, is our ability to support mounting drives. This has been a big ask from our community and something that we've been excited to support. So when you mount a drive in Linux, what happens is we go out and look at your available drives on Windows. So if you have a file system that you want access to and it's supported on Windows, you can mount that thing directly inside of the Windows Subsystem for Linux. So here we have a flash drive plugged in. It's listed in Windows as the D drive right here. It's got some top secret information in there. And we just mounted it. And now it shows up under Mount, and D is, I believe, where Gilles just mounted it. So we can go into that flash drive. We can list the directories. We can cat the top secret file if we wanted to. And all of that works just like you think it will. So that's all I have for my demos. Now we're going to bring Gilles up to the stage, who's already here, to talk about some of the improvements that have been made to the Windows console over the past year.
So, the Windows console. Let's take a look at what the Windows console is and how it interacts with the system. This is very important because that's the hosting environment for WSL. Without a console host, applications don't render on your screen. So when you think of a console, there's actually two processes running. There is the console host, which is the window with which you're interacting, and then there is the application. So the application can be CMD, Bash, PowerShell, or any of the command line applications from Linux or Windows. So the host is providing a window. It is the one rendering to the screen. So when you change fonts, it is the console host that responds to that request. When you change colors, again, that is the console host. But the application, so when we make modifications to the host, all applications can make use of them. They might need to go and make slight modifications to their code to take advantage of new features, but most of the time, they can get benefits for free. For example, when we added support for high DPI displays in the console host, every single application then started rendering crisply on high DPI displays because they're leveraging the power of the host. So how do these two applications communicate together? So there are two ways. The first one is through APIs. So the console host provides APIs for the applications to get state and set state. For example, an application can call an API to change the color of the cursor. A build application can change the color that it's outputting to red when an error message comes up, so that you can quickly see that, oh, I've got an error in my build. Or an application can query state. For example, querying the width of the window to display a progress bar that fits the window and not just an arbitrary size. Another way to communicate is through streams. The most common one, you have three streams in the console: standard in, standard out, and standard error. So the input stream is when you're typing into the keyboard, or if you're redirecting input from a file, for example, or a pipe. The output stream is what you're displaying, and the error stream is what you're displaying as errors. So for example, when you do a printf command, the application essentially sends the string that it wants to display to the console host, which will take care of making it appear on screen or in a file if you're redirecting. On Linux, they don't use the APIs. What they do is they have control sequences that are embedded in the streams that they use. These are called VT sequences for virtual terminal and have a specific format. They usually start with an escape character, symbols. You might have some parameters like on the one displayed here, which is to change the color of the cursor, and then something that tells that the sequence is ended. So here it is the M that specifies that the command to perform is to change the colors, and then you have the parameters in the middle because they can be variable length. So if we look, we'll go back into how these work, but because these are embedded in the streams, an application can just write directly to the stream and control how things work. So to go back to the example of the build application, instead of having to call change the cursor color when I have an error message, they can embed that into their printf statement, and automatically the color will get changed when they output a string. So we know that the console is where we get our work done. As developers, this is a very powerful set of tools. So about 3 years ago, we had a small team of developers that was told, okay, let's look at the console and finally look at improving it. The console subsystem in Windows has been one of the first things written for Windows and hasn't had much love for a very long time. This is changing. And so we've looked at how can we improve the way the console works. It's typically been, we need to support something new, let's cram it in the console and just make it work. This is not the case anymore. This is really, let's look at improving usability. So we started improving, modernizing a little bit at a time. We added reflowing and resizing, a better copy and paste selection experience, and little things that just make the console experience better. As I said, this is a very old code base. Over the last 20 years, many, many improvements have been made to engineering practices. And so we started looking at those and figuring out how can we make sure that we use better engineering practices to make the code more solid, better, and help us improve it long term. With the anniversary update, we added support for VT sequences. This was critical to support WSL, because that is the language that Linux applications talk. We added better font support. Now you can essentially choose any monospace font in your console. making it more personal, and allowing you to choose what you like. We improve rendering. But again, being the host for WSL means compatibility. The console needs to work the same way that a terminal works on Linux. Applications don't look at, is this running on Windows or is this running on Linux? They expect behaviors, and we have to support those behaviors. What are we doing for the creators update? So we went from 16 colors to 24-bit colors. What does that mean? You had 16 colors that you could choose from to display everything that you wanted. While that might seem like it's okay, you can get so much more richness and convey more information by having more colors. And there are so many apps that take advantage of that. Fish, Vim, Midnight Commander, all applications that want to display more colors than 16 and really convey information through that differentiation. We added more VT support, more WSL compatibility, Tmux, Vim, Emacs. They all work so much better in the creators update than they did in the anniversary update. We added mouse support. You might be thinking, why would I use a mouse in a command line application? Well, there are scenarios where you have lots of controls that you want to target directly. You have Midnight Commander as a file manager. If you can go and select a file directly instead of having to scroll, it makes a better experience. It's the same with HTOP. And because we also support touchscreens, input can be both a mouse, a pen, or your finger. I mean, that is why it's coming from the console host, and the application just gets touch input for free. And we continued our engineering work. Anecdotally, one of the developers on my team, as he was working on the console, found a comment from before he was born that something had to be changed. This is just a testimony of how good and old the code has been. And by continuing our engineering effort, this enables us to innovate more rapidly. So we know that we've got a lot of things that we want to do, and by instilling these better engineering practices, we want to be able to get to these things quicker. And now let's wake up Jack's machine.
Have Jack type in his code.
Does anyone remember what his code is?
We'll just log in via normal now. That's all right. There we go.
All right, so I've talked about VT sequences and the fact that they are just control sequences embedded in the streams. So let's see how they work. Let's change our prompt and make it a little more personal. So we'll type prompt. $E sends the escape code, open bracket. 37 will select 47. Is it?
45.
Oh, sorry, 37 will select the foreground to be the 7th entry in our palette. 1 makes it bright. 45 selects the 5th color in our palette for the background. $P will output the, no space between the P. $P will output the path. Then $E, no space between the.
It's a complicated sequence.
Yes. $E for another escape sequence and restore the color back to the original color. So $E, open bracket, 0M. Now a space. And because we support Linux, let's change our prompt to have the $sign. So $E, open bracket. And we'll choose the 2nd color in our palette. I like it bright. And then we'll do $to display a $sign. And then let's restore the color back. So $E open bracket 0.
That's on whether that's what.
M. No. Oh, yeah. This one.
Oh, yeah.
Thank you.
There we go.
And 0M. Perfect. So prompt hasn't been changed to support escape sequences. But because it comes from the console host, and as soon as the characters get into the stream, the console host knows how to interpret them. So now let's look at, so we said we added 24-bit color. So let's look at what that means. So I've got a text file that contains escape sequences to change the cursor and show the 24-bit color support that we have. So we can just type.
Oops.
So we can type the file, and it will be displaying those colors. Now, how does it look on the Linux side? Let's get into Bash and do cat, which is the equivalent of type, with the same file. And lo and behold, it looks just the same. And as you can see, we have a nice gradient showing that we have much better color support. So finally, let's look at some of these improvements for Linux. So Tmux is a window manager for console mode applications. So from within one window, you can have multiple panes and run multiple workloads at the same time. So let's split it up. On the top, we're using Midnight Commander. At the bottom, we'll use htop and look at our resources. And then on the left, it's been a really bad winter for Seattle, so let's warm ourselves up and run a little fire. So if we look at what's going on in htop, let's see what's using the CPU. So now we can use the mouse. Yeah, switch to the,
Yeah. There we go.
so we can use the mouse and sort our CPU, our processes by CPU usage. And we notice that unfortunately our fire seems to be really driving the CPU up. So let's kill it. So we can just use the mouse, sigterm is fine, and send the kill signal, and all of a sudden, the app disappears. So these are the things that we've done to help improve how Windows supports Linux applications. I'll give it back to Jack to continue talking about what's coming up for WSL.
Thanks, Joe. That is some super cool stuff, and we're excited to be working with the Windows console to just make an even better integration at an even higher level. So future console work is something that Jill is actually going to come back up and talk about right now.
So we're not done with our journey to improve the console. What are we doing in future console work? We're going to keep making usability progress. We know that there's a bunch of features that everyone is asking for. We're looking at them and trying to see when we can deliver those. We're improving accessibility. Not everyone has an easy time working inside of a text-based editor. People have vision impairments. By plugging in the console into our accessibility pipeline, we can give people with impairments a much better console experience, allowing them to get their work done. We're making so many more internal engineering improvements. I can't stress enough how much we see the code, and we have to make sure that the practices that we use and the bringing this code base into the 21st century and working through our backlog. We've got feature requests that are miles long, and so we want to get these done. And listening to our users. I mean, we have a user voice page, we have communities, we have very, very vocal enthusiasts. We want to hear what you guys need so that we can prioritize and make sure that you have the best console experience on Windows. And now to get back to WSL.
Thanks, Joe. So this is actually the really fun part of this talk. We've gone through a lot of the technical details, what enables this, seen some cool demos, but I'd really like to focus now on what's coming next. These are the features that you've asked us for and that we have worked so hard on that we're very excited to bring to you in future versions of Windows coming this fall. So in the next release, we're going to focus very strongly on compatibility. We're going to be looking at those tools and applications, that big list that you saw earlier, and so many more, to ensure that they're running at the level that you expect. We're going to test more and include more unit tests inside of our unit test framework, ensuring a rock-solid, stable, performant environment for you to do your work in. If you've been on insider versions of Windows for the past month, you've known that we already have serial support available for you. This is taking COM ports that show up in Windows and converting them to a TTY session, TTY handle inside of WSL. This is super cool and allows you to use WSL to interface with things like Raspberry Pis or Pixhawks, embedded applications. If you have a USB to serial converter, that will work well as virtual serial devices, applications that may rely on that kind of thing. The file system. This is something that we hear a lot about and something that we think is one of the most important aspects of this project. Support for things like SMB, FAT32, and USB drives took a while to get going, but we're now reliant on the Windows NT file system and their support for these things. And so anything that the NT file system supports, you will now be able to mount directly inside of Bash and WSL. In addition to this, we're going to work on performance. We know that this is an area where we lapse in some of our performance testing. So we will be improving that in the coming versions of Windows. OpenCL with specific support for TensorFlow. Machine learning and accessing the graphics card to do this kind of thing is something that we've heard a lot from our community, that this is a big topic that they want to get involved with, and they want to use WSL for it. So we're going to be very excited to support that. We're going to be on server. This is also a big ask that we've had. People want to be able to use WSL in a server environment, not necessarily to run their production code. There's great services on Azure available to spin up Linux or Windows VMs. This is more if you have a Windows server out there and you want to talk to it via SSH or do some basic text-related munging, or grab some logs, or spin up a non-production critical web service. WSL is going to be there for you, and now will be available on server. Lastly, we're going to support multiple distributions. If you watched the keynote yesterday, you already know this, but we are going to support not only Ubuntu, who again has been a great partner with us for the past year, but SUSE and OpenSUSE, Fedora, and you're going to be able to run them all side by side. This, I think, is groundbreaking. There is nothing out there that will let you do this in the same way. A VM running this same setup would have a massive amount of reserved memory and overhead. This allows you to have a very lightweight footprint, WSL, and run all three of these distributions at the same time. We are incredibly excited, and we think you will be too as soon as you try it out. You're going to be able to download these all from the Windows Store in a very seamless installation process. So that's all the content that we have for you today. I would encourage everyone in this room and everyone that's watching this recorded session to please go try WSL. WSL is an incredible product, but until you really put your hands on it and start to type in the terminal and get the feel for what's possible, I don't think you can fully get it. So please go try it. Bring your stack, download, clone your Git directory, and just see what runs. If something doesn't work, give us feedback. We have an incredible community, a GitHub that is thriving. Go take part, go ask questions, get involved in the conversation. Help us prioritize future features on our user voice page. If you want to learn more about WSL in general or Microsoft products, there's some links here. The first one is a link to our blog. I would encourage you to go out and read that. We have hours of technical talks recorded with our developers, diving deep into these technologies and giving you insight into what really makes this product work, as well as overviews of some of the new features that we've been working on and the testing that we've done on the product. If, for some reason, you would like to follow me on Twitter, there is my Twitter handle. Gilles is there as well. Thank you very much, and I believe we will now have about 10-ish minutes to take some questions.
Okay, hi. So I'm assuming I can use a WSL to build a native Linux application from the console. Can I then debug that with Visual Studio?
Absolutely, that's a great question. So we've had people that have gone out and been able to attach debuggers using GDB inside the Linux environment and set those breakpoints visually within Visual Studio. So I would encourage you to go look at some of the Visual Studio's documentation that's available for this. That is definitely a scenario that we support, yes.
Cool, thank you.
Yeah.
Okay, I'm going to expand on that because I was going to ask the same thing. But they had shown in one of the keynotes actually like having a separate VM running in Ubuntu and connecting Visual Studio via the VM and stuff like that. Is there plans to make the integration a little bit more tighter so we don't have to kind of do the workarounds you talked about?
Absolutely. That integration between WSL and the tools that you use in Windows is something that we're working very hard to increase. Specifically with the Visual Studios, I believe that the way that worked is they piped it over a network connection. Right. The networking stack on WSL and in Windows is the same. So anything that you pipe over that will appear just as you expect it to.
I was good. You mentioned a bunch of file systems. Is ext going to be something you guys are looking at, like 2, 3, 4, any of those, being able to mount those?
So we've heard a lot of asks for ext, and it's obviously something that a lot of people use in their scenarios. Unfortunately, we're reliant on the protocols that are supported, or the file systems that are supported by Windows. So think of WSL as sort of inside of the bounds of what Windows is capable of. And currently, Windows does not have support for that, so no. But it is something that we're looking at, yes.
Do each of these bash windows you open up, are they effectively sandboxed, or can they talk to each other? Are they on the same kernel? And as a follow-up, when you say you can install multiple distributions, how does that work? Aren't they all going to want to install files at the same place in the file system?
So I'll touch on the second part first. So the way that the Windows Subsystem for Linux works is it has a separate home directory. This is where your Linux files exist. It's something that we call LXFS, and it exists as a system file on your disk. Now, when you install multiple distributions, each one of those will have its own directory to keep track of its own Linux-related files. It's things like opt and proc and things like that. Now, WSL interfaces really well with the file system on Windows, so all of the Windows files that you have will be shared not only with your Windows OS, but also with every other distribution that you have available. So you'll be able to, it'll be pretty seamless, I would imagine. And I'm sorry, what was your first question? About the open different windows, that's right. So when you open up multiple windows of bash, they're all communicating with the same instance. They're all going to have the same PID. And yeah, does that answer your question?
Yeah, I think so.
Yeah, so it's basically all the same instance. As soon as you close it down and bring up another one, it's a fresh new instance.
So if you memory mapped a file, you could talk to that memory block from 2 different windows. That's kind of the application I was thinking
I
of.
believe that would be possible. I'd have to check though. Thanks.
You might not be able to do it through multiple, through different distros. Fedora might not be able to talk to Ubuntu through a memory map file, but they would be sharing, though, the same networking stack. So if you do have a web server running on Ubuntu, you can access it from a database used on Fedora.
Right. Okay.
Yes, when I go into my home directory under Linux under WSL, I notice it's got paths like /mnt/c/users/ my username /app data /local /lxss/home/root/fs.
Yeah. So the question.
Path can't be translated if I do notepad.exe space some file name. It won't translate that long path back into Windows after it opens.
Yeah. So to restate the question is. There is this directory that's a system directory inside of our app data folder. We've marked it very specifically as a system folder Now you can go in there, obviously we're all pro users, we know how to unhide system folders. We can go in there and edit stuff and use our Windows applications to edit those files. Unfortunately, there's a layer of caching that we do right now between LXFS, our Linux files that are in that folder, and the NT file system, NTFS. So if you were to use Windows tools on those, like your bash RC or anything inside of proc or anything like that, it's not going to work like you expect right now. That's something that we're working on, is integrating those two at a better level. But for now, I would encourage you not to go into that directory with either File Explorer or Windows applications.
Okay, so maybe in 6 months to a year, I'll be able to notepad a file in my Linux directory.
It's certainly something that we're looking at, for sure. There's a question in the back.
Will you be adding any tighter integration with graphical support?
Graphical support is not actually something that we initially set out to support. That's one of those things about this project where we'll be going through and implementing system calls, and all of a sudden this whole suite of applications that we didn't even expect now lights up. GUI support falls into that category. It wasn't something that we initially went after. I mean, we're very focused on the web developer, someone who's in the console, has a text editor open and a console open, and they're sending something up to Heroku or some web service. We've heard a lot.
I think a lot of us have found a workaround, to use it like X window or serve it up or something.
I have seen a lot of workarounds. There's a lot of cool projects, and we kind of see it as just that, like cool example projects of things that are possible. Right now, that's not one of the main features of the Windows Subsystem for Linux.
Okay, great.
Why do you have to turn on developer mode? It have some problems when I need to ask administration permission to do that.
Yeah, developer mode is an administrator gate. So developer mode is just a way to bundle a lot of settings and tools that you need to do your development on Windows. We're looking at the applicability of that switch to WSL, but for now, you get a lot of tools. I mean, we download some things when you flip that switch. Now, if you see a warning or something during that time period, that doesn't affect the ability of WSL to run. And you're correct, it is administrator gated for right now, and that's the way it will maintain, at least for the future.
It's blocking my progress in our organization.
I understand, yeah.
Two quick questions. One, from my C# app, can I call create process and start up something from the WSL? And my other question was, from a PowerShell script, can I detect if Ubuntu or SUSE or one of the other subsystems is installed?
So two questions. One, from my C# app, can I call create process and launch something from the WSL side? So to answer that, that is yes. For now, if you launch bash-c and the rest of the command that you want to run, that will launch from any create process. So that enables you to launch something from the Linux side, from your Windows side. Two is, can I detect if WSL is installed? At the moment, we don't have any specific data or way to say which is installed. That is something that is very interesting that we can start looking at.
Question in the back?
Yeah, earlier you said that daemon's support isn't there yet. And if you close the window, then your bash session is done, is closed out. So if you're running an SQL server, is there graceful closing on that, or does it just crash the server?
I don't know for sure what signal is sent to the process before the window closes. I would have to go and check on that. In general, the statement that we don't support daemons I don't think is exactly correct. It's that we don't support daemons running when the console window is not open. So you can run any system service that you would expect to run in Linux directly inside of WSL, but it's just about whether or not that will stay open when that window is closed.
Okay, thank you.
Are you planning on supporting a non-internet connected environments for installing the WSL?
Yes. So we are looking at different ways of enabling people to install WSL when they are not connected to the internet. I don't have details currently that I can fully share, but it is something that we are looking to support. We know that many organizations want this functionality, but don't necessarily allow their workstations to be connected to the internet.
Thank you.
We probably have time for about one more question if we have one. If not,
Sure.
oh, sure.
Are you planning on allowing people to set up their own Linux user spaces that aren't based on those existing distributions you created?
That is, I'm assuming you're referring to different distributions besides the ones we've listed. Yeah, that's certainly something that we're looking into. We'd love to be able to support, especially community distros. Yeah, it's certainly something that we're looking into.
Thank you.
Thank you all for coming.
Thank you.